most kids, you start thinking at an early age, as soon as you look in the sky at night and you see stars, and you think, what would it be like to be up there?
Definitely look up and see the stars like you have never seen them before. I mean, the Milky Way is just stunning.
There's many things in the cosmos to gaze at it. For example, the Magellanic Clouds. Those show up really bright and vivid because you don't have atmospheric scattering. You can see Andromeda, the spiral galaxy of Andromeda.
Of course, the lights don't flicker. They're steady because they're not coming through the dust and coming through the atmosphere. And then as you really adjust, you start to sense the very subtle colors that are in the stars. A little bit of reddish, a little bit of bluish, blue-white.
Just all the colors and the light come out, in that depth of space as well.
I could all of a sudden detect depth. Now, I couldn't tell you how much, but it's light years, right? And it's like, whoa, I can somehow tell that star is closer than that star. And that was something that knocked my socks off. And I thought, nobody told me about this.
I don't think I had thought before going up there about how many stars you see, the density of stars.
You see so many stars, it becomes hard to pick out constellations. People ask if there's aliens, and I'm like, of course there are aliens. Look at all those stars. There's got to be.
It's just so vast and infinite. I don't know what else to say about that.
Finally, it's launch day.
Launching to space, of course, was a momentous experience.
You see that this rocket is a living, breathing beast. The thing is alive, and it wants to go.
It suddenly feels like it's real.
First thing, you're strapped into the space shuttle on the launch pad,
and I can say sitting in the rocket, getting ready for launch, you're anxious and you're excited.
And waiting for countdown, focusing and doing your checklist, focusing on your procedure.
At the moment of launch, you're quite prepared.
Lights off and you feel the rumble, and then you start to move, and that constant smooth acceleration pulling you back in the seat.
And you feel like you're just in a car wreck because the solid rocket boosters light off and they give you a kick in the backside like you were just rear-ended at a stop sign, literally.
There's just nothing subtle or nice about it.
There was the vibration, the pressure, the acceleration, the pressure in your seat.
I distinctly remember the point when I stopped and thought, I did it. I'm here. My goal was to be an astronaut, and now I'm in space.
As a kid, you maybe fantasize about spreading your arms and flying among the clouds and that kind of stuff. That's what we're doing. Floating is very cool.
Being weightless the first few days is horrible. I mean, it's really neat to see something floating in front of you. It's really horrible to feel like you're going to throw up all the time. And then as you start to get into it, you start to realize that the human's an incredibly adaptive machine, and weightlessness is really, really well suited for us.
Pretty soon you're going into a hatchway and you come through and you kind of push off on both sides and you go zipping down the middle and you're turning right at the end. So you reach out, grab a handrail, and
It's as fun as you think it would be, only better. Because I don't have a very big vocabulary, so I tried to use the biggest, most impactful words I could.
Everybody's a superhero. You're not floating, you're flying.
It's about a day to get to the International Space Station. It's about a week to get to the moon, but it's over a year to get to Mars. But if you were on your 2.5 to 3 year trip to Mars and back, one of the other important missions of the International Space Station is to be a proving ground for our technology to go into deep space. We develop control systems to produce oxygen and scrub carbon dioxide. And what we found out is that a lot of those systems, they were failing a little bit early, a little bit before we expected them to. ISS offers those opportunities to be able to find out those things. You can't learn it anywhere else but up on the International Space Station. You have an engineering achievement where the world has come together, put their best minds from each country together to develop a capability like this. We'll use those systems and technology that we developed during the International Space Station program for deeper and deeper space activities.
How do scientists and engineers communicate with faraway robotic spacecraft exploring our solar system? When scientists and engineers want to send commands to a spacecraft, they turn to the Deep Space Network, NASA's international array of giant radio antennas used to communicate with spacecraft at the moon and beyond. Operators at the Deep Space Network take commands, break them into digital bits, precisely aim these big antennas at the spacecraft, and send those commands to the spacecraft using radio waves. But what are radio waves really? Well, to start with, you probably already know they're part of the electromagnetic spectrum, which includes other kinds of waves and light that you're familiar with. Electromagnetic energy is a type of energy that can travel through space as waves that have different properties, depending on the size and spacing of the waves. These waves span a broad spectrum, from very long radio waves to very short gamma rays. The human eye can detect only a small portion of this spectrum, which is why it's called visible light. Radio waves are the longest in the electromagnetic spectrum, and the wavelengths used by the Deep Space Network currently range from about the size of a dime to the size of a dollar bill. Radio waves are all around us. We use them when we listen to music over the radio, or send emails from computers using Wi-Fi, or when we talk on cell phones. Computers and cell phones are actually just high-tech radios. Radio waves also travel really, really fast, at the speed of light. That's 186,000 miles per second. But our solar system is also really, really big. It could take several minutes or even hours for the radio waves to reach a spacecraft. Once spacecraft receive the signal, they execute commands, collect scientific data and never-before-seen images, and send all of that data back to Earth as digital bits, which are gathered by the huge antennas of the Deep Space Network and distributed to scientists.
And to make sure you don't miss out on anything mind-blowing happening in our universe by subscribing. Thanks for watching.